So this is the question asked in GATE 2019 Electronics and Communication Engineering paper, in which you have given a signal flow graph corresponding to x of 1 as shown in figure, and you need to find out the coefficient a1 and a2 and a3 in terms of w of 6 of fast Fourier transform. So the NPTEL reference for this question is discrete time signal processing by Professor Mrityunjay Chakravarty, IIT Kharagpur. So the useful data for this question is that for a given signal x of n, you can find out the fast Fourier transform x of k, which is equals to summation n equal to 0 to capital N minus 1 x of n into w of n kn, where n is from 0 to n minus 1. So this is the first useful data, and the second useful data that you should know the property of w of n. So if you have given w of n to the power k plus n by 2, then this one equal to minus of w of n k. And the third one is that w of n to the power 0 is equals to 1. So in the question, you have given this signal flow graph where x0, x3, x1, x4, x2, x5 are connected to x of 1, and you need to find out x of 1 and give the a1, a2 and a3 in terms of w of 6. So from this signal flow graph, you can write x of 1 as x0 times a1 minus x3 times a1. Similarly with x1 times a2 and minus x4 times a2, x2 times a3 and minus x5 times a3. So you can write this a1 times x of 0 minus x of 3 plus a2 times x of 1 minus x of 4 plus a3 times x2 minus x of 5. So this way you can write x of 1. So from the definition of fast Fourier transform, you can write x of k as summation n equal to 0 to n minus 1 x of n w of n kn. You can write for n equal to 6, you can write summation n equal to 0 to 5 x of n w of 6 kn. So by putting k equal to 1, you will get x of 1 as x of 0 w of 6 to the power 0 plus x of 1 w of 6 1 plus x of 2 w of 6 2 plus x of 3 w of 6 3 plus x4 w of 6 4 plus x of 5 w of 6 power 5. So the property of this w is that w of n k plus n by 2, which is equal to minus w of n to the power k. So from this property, if you put k equal to 0 and you have given n equal to 6, then the first condition you will get w of 6 and 3 is equals to minus w of 6 0. So w of 6 0 is nothing but is equals to 1, so it becomes minus 1. So the second, when you put k equal to 1 and n equal to 6 you have given, so you can find out that w of 6 4 is equals to minus of w of 6 to the power 1, which is also equal to minus w of 6, because minus w of 6 to the power 1 is equals to minus w of 6. The third one, if k equal to 2, then you can write w of 6 to the power 5 is equals to minus w of 6 2. So we will put these values of w of 6 to the power 0, w of 6 4 and w of 6 5 in this equation 2, and let's suppose if this equation is 1, then by comparing equation 2 and equation 1 you will get a1 and a2 and a3 in terms of w of 6. So I am putting these values of w of 6 3 and w of 6 4 and w of 6 5 in the equation 2. So by putting in equation 2, you will get x of 1 as x of 0 plus x of 1 times w of 6 plus x of 2 w of 6 2 minus x of 3 minus x of 4 w of 6 minus x of 5 w of 6 2. So by rearranging this you will get x of 0 minus x of 3 plus x of 1 minus x of 4 w of 6 plus x of 2 minus x of 5 w of 6 2. So your equation 1 was given as a1 times, that is x of k, was given as a1 times x of 0 minus x of 3 plus a2 times x of 1 minus x of 4 plus a3 times x of 2 minus x of 5. So by comparing these two, you will get a1 as 1, your a2 as w of 6 and a3 as w of 6 2. So the correct answer for this question is option C.